Hello everyone. Welcome to the world of color in digital printing. In this video, we will explain the basics of color adjustment and color management in printing. We will start from fundamental concepts and then move on to practical methods. Have you ever noticed that printed colors do not look as expected? Or that the color changes from one print to the next? In printing, color is more than just appearance. It affects brand image. It defines product quality. And it directly impacts customer satisfaction. If color management is not done properly, it can lead to reprints, wasted time, higher costs, and customer complaints. However, with the right knowledge and correct procedures, these problems can be avoided. By applying proper color management, you can produce stable, high-quality prints more efficiently. This video will help you understand color better and provide useful tips for your daily work. First, let's look at how digital printing systems reproduce color, and how we manage that color. Color in digital printing. Let's begin with how color is reproduced on paper in a digital printing system. Digital presses use 4 toner colors, known as CMYK. These are cyan, magenta, yellow, and black. Each toner represents a single color. By combining these colors, the press can create blue, red, green, and many other colors. Toner-based printing uses a method called subtractive color mixing. When toner is placed on white paper, part of the light is absorbed. The remaining light is reflected, and this reflected light is what we perceive as color. In theory, mixing equal amounts of cyan, magenta, and yellow should create black. In reality, the result is a dark but muddy color. To produce a deeper and cleaner black, and to reduce CMY toner usage, black toner, K, is added. Color is not printed as a solid layer. Instead, it is expressed using many tiny dots called halftone dots. By changing the size and density of these dots, the printer creates light areas, dark areas, and smooth gradations. Through the combination of CMYK toner and halftone control, digital printing systems can reproduce a wide range of colors. The lab color space. Now that we understand how CMYK toner produces color, let's look at an important challenge. Colors such as CMYK, or RGB colors on a monitor, are device-dependent. This means the same color values can look different on different devices. For example, even if the same cyan value is specified, the printed color may vary depending on the printer model or manufacturer. Because of this, it is difficult to define color precisely using only CMYK or RGB. To solve this problem, we use the lab color space. The lab color space is a device-independent color space defined by the International Commission on Illumination, also known as the CIE. It is based on human visual perception. Because lab is independent of devices, it allows color to be expressed as numerical values that remain consistent across systems. Lab describes color using 3 axes. L star, which represents lightness. A star, which represents the green to red axis. And B star, which represents the blue to yellow axis. Lab values are measured using a device called a spectrophotometer. This device measures the light reflected from or transmitted through an object. The measured data is then converted into lab values. By using lab values, we can manage color objectively using numbers, rather than relying only on visual judgment. ICC profiles. Now that we understand lab as a common language of color, let's move on to ICC profiles. An ICC profile is a data file that describes how a specific printer and paper combination reproduces color. For example, the profile may indicate that applying specific CMY toner values on a certain paper results in a particular lab color. On a different printer, the same lab color may require different toner values. ICC profiles account for these differences. They allow the same color to be reproduced consistently across different devices. Konica Minolta printer color adjustment procedure. Now that we've covered the fundamentals, let's look at the actual color adjustment steps. Here, we will follow the standard color adjustment procedure for Konica Minolta printers. The process is divided into two main stages: single color adjustment and mixed color adjustment. Single color adjustment prepares a stable foundation. Mixed color adjustment ensures accurate color reproduction using ICC profiles. Let's go through the steps one by one. 1. Density uniformity across the sheet. This adjustment corrects density unevenness across the width of the paper. In other words, it eliminates differences between the left and right sides of the print. The goal is to achieve uniform density across the entire sheet. Once this is done, color measurements can be taken from any area of the paper with consistent results. 2. Maximum density adjustment. This step ensures that each CMYK toner reaches the target density at 100% output. By aligning the maximum density of each color, the darkest areas of the print become stable and consistent. 3. Mid-tone adjustment. Mid-tone adjustment can be performed on the printer engine or the controller. In this step, the density of each CMYK toner is finely adjusted from 0 to 100%. This ensures smooth and accurate tonal gradation. After completing density uniformity, maximum density, and mid-tone adjustment, single color reproduction becomes stable. Next, we move on to mixed color adjustment by creating an ICC profile. 4. ICC profile creation. A printed color chart is measured using a color measurement device. Based on this data, an ICC profile is created to link single colors and mixed colors. This allows the entire color space to be managed accurately. Over time, printer characteristics may change due to paper variation or aging. For this reason, ICC profiles should be reviewed and updated regularly. Common mistakes. 1. Relying only on visual judgment. Visual inspection is important, but human perception changes depending on lighting and environment. To improve accuracy, numerical color management should be used together with visual evaluation. Numbers provide an objective reference. Visual checks help fine-tune subtle nuances. 2. Assuming single color adjustment is enough. Even when CMYK single colors are well adjusted, mixed colors may not appear as intended. This is especially true for gray tones and skin tones. This happens because toner overlap and fixation behavior differ between single colors and mixed colors. Therefore, mixed color optimization using ICC profiles is essential. 3. Forgetting that ICC profiles are paper-specific. ICC profiles are created for a specific printer and paper combination. If the paper changes, color reproduction also changes due to differences in whiteness, gloss, and toner fixation. When paper is changed, a new profile must be created or updated. Using an incorrect or outdated profile is a common cause of color mismatch. 4. Directly editing color data in the original file. Directly editing color data in the original artwork is not recommended. Matching colors on a monitor through trial and error increases time and printing costs. It also leads to unstable results. Even if it works once, it is usually only a temporary solution. For stable and efficient color management, color adjustment should be done through proper calibration, not file editing. 5. Risks of adjusting only with tone curves. Adjusting color using only tone curves requires caution. Tone curves directly modify CMYK output and can distort the color gamut. Even if CMYK values look correct, secondary colors may not be accurate. Before using tone curves, proper basic calibration should always be performed. 6. Ignoring environmental factors. Temperature and humidity affect toner fixation and paper behavior. Differences in toner or paper lots can also influence color reproduction. By keeping the environment stable, more consistent color results can be achieved. Daily automatic calibration is very effective in reducing environmental impact. This concludes our introduction to color management in digital printing. Thank you for watching.